In today's tutorial, we are going to take on some problems on power sources, and towards the end of the tutorial, I'll introduce you to Tinkercad and probably give a small assignment on that. Okay, so the first problems goes like this: which of the following circuits in the following figure will give you terminal voltage of 7 volt DC output, right? So can anybody guess what would be the answer? It's pretty simple. Any one of you? We learned that voltage sources, it will just get algebraically added, right? So what would be
D.
yeah, D. So if you see here, this is an plus 5 volt plus 3 volt, so they will get added, and this is connected in the opposite polarity. So you will have minus 1 volt. So 5 plus 3 7, 5 plus 3 8, and minus 1. So the net voltage available at A and B will be 7. For the others, you can see that the total algebraic sum will not be 7 volts. So this is a pretty simple problem. In the second one, what we need to find V0. V0 is the voltage across this 8 ohm resistance. So the problem says use source transformation. So we have two sources. One is a current source, which is 3 amperes. Here the current is flowing down out here, and then you have a voltage source of 12 volt. Okay. Which of the sources it would be better to convert into we can convert this voltage source into a current source, or alternatively we can convert this current source into a voltage source, right? So which would simplify the circuit? Anybody? Right? If you see, if we convert this into a voltage source, right, so you will have a 4 ohms coming in series. So that and 2 ohms will get right in series, they will become 6 ohms. So let's start by converting this 3 ohms 3 amp current source into a voltage source. So you have 3 amps, 4 amps, and this is the same circuit. So now we have converted it into like we know the voltage conversion rule, right, that Ohm's law has to be satisfied. So 4 into 3 is 12 volts. So 12 volts voltage source and 4 ohms in series. So this current source in parallel with the resistance has been now converted into a voltage source in series with that 4 ohm. So what is important here is the same mistake you might make in exams. You have to be careful with the sign. If you see here, it is plus is in the bottom and negative is in the top, so that the current flows in the in this direction from top to bottom, because if you see the 3 amps here, it is flowing top to bottom. So you have got to be careful with the signs which you are going to assign after the transformation, right? So this is plus here and minus here. So this 4 and 2 is going to be 6 ohms. So again 4 and 2 is going to be 6 ohms. Again we can convert it back into an current source here. So 4 plus 2 is 6 and 12. So if you have to convert it back into a current source, so 12 divided by 6 will be 2 amperes. So 2 amperes bottom, and then 6 ohms out here, right? And then you have 4 amps which is going on top. Again in this also you have a 3 ohms and a 12 volt source out here. This can be again converted into an current source. That is 12 divided by 3 is 4 amps, which is going, now the direction is top because you have a positive voltage here on the top. So 4 amps and 3 ohms. So now these can be simplified. This 4 and 2 can be combined. These two current sources can be combined into an 2 ohms which is going to top, and this 6 and 3 ohm resistance can be again combined into an parallel of 6 ohm and 3 ohm is going to give me 2 ohm, and this parallel of 2 amps current source and 4 amp current source is going to give me 2 amps, right? So hence this circuit has now become pretty simple, right? Now we can easily compute what is the voltage across V0, right? To find out what is the current which is flowing into 8 ohm, we have the current formula, right? Today probably I'll cover it in the theory class. Otherwise it will be 2 into 2 2 ohms divided by 8 plus 2 ohms. So that way we can compute what is the voltage across the 8 ohm resistance. Is this clear to all of you? Anybody has got a doubt on how to go about solving these kind of problems? It's pretty straightforward. If you have any issues, please speak up, or you can even want to write anything in the chat box, you can do that also. No problem with that. I have a dual screen, so I can see the chat message also.
Okay. Sir, you are not recording?
Yeah, I am recording it, right? You can see on top of that the counter is moving it, right? I am recording it. Okay. This is how you compute the current which is going into the 8 ohm resistor, 2 amperes into 2 divided by 2 plus 8, which gives the current in this, and then by multiply it by 8 you get the output voltage. Okay. So is this problem clear to all of you? Okay. Then I will go ahead and find. Okay. Now this is actually an equivalent circuit of an amplifier. What an amplifier does is, when you apply an input signal, it will have a huge input impedance. Okay, this R2 is known as the input impedance of an amplifier, which will be huge, like it is in kilo ohms range. Okay, so whatever is the voltage across this input terminal will be amplified by a certain factor, which is known as the gain. Here in this example, the gain of the amplifier is 100 ohms, and all practical amplifiers will have some output resistance, right? That is, it is not an ideal source, so there will be some series resistance which is 100 ohms. So we need, this is the load resistance which we are going to connect, which is 100 ohms again here. So this is the voltage which we have applied, and this is the output we are going to take. Okay, so now we need to find out what is this voltage at the output. So this is how, this is actually an representation of an amplifier. Okay. So if I go out here, so the first step would be to find out what is the voltage across VR2. Okay, this the voltage across this R2 resistance, because that voltage is going to get amplified by a factor of 100. The gain is given as 100. Okay, so whatever is the input voltage we give, a fraction of that will be available as an input to the amplifier. So this generally becomes the because all the sources will not be ideal sources, so this 1K is generally the source resistance, right? So so along with the source, there will be a series resistance. So a portion of the voltage which we apply will actually be available to the amplifier. So what is that portion available to the amplifier input? We need to find that. So the equation will be like this. Again, this is an voltage division rule, where we have this Vs which is applied out here. So the voltage across R2 will be Vs into R2 divided by it's written R2 plus R1, so there is an error, it should be R1 plus R2, right? So R1 plus R2. So this is 1 plus 5K, and on denominator you have on the numerator you have 5K into this voltage whatever is applied here, so 0.1. So 0.0833 is the voltage which will be available to the input of the amplifier. Is this step clear to all of you? Okay. Okay, if you have any doubts whatsoever, please interrupt me then and there. Okay, now this voltage will be amplified by a gain A, right? So it is AR2. It's not that an amplifier will amplify this 0.1 volt. It's only the portion of that input voltage which is available as the input to the amplifier will be amplified. Okay, so this voltage will get amplified by AR2. Again, not that whatever is being amplified, the entire voltage will not be available at the load, because it will have a series resistance. So again, there it will act like a potential divider, and a portion of the voltage, which is a fraction of the voltage which gets amplified, will be available to the load depending on the ratios R3 and R4, right? So if you see, again we apply the same rule out here. So this is AVR2, okay, this is the voltage which is generated here, and R4 is the load resistance which is connected here, divided by R4 plus R3, because some voltage will get wasted across this R3 resistance, which is the output resistance of the amplifier. So you substitute these values, you get 50 VR2, right? And then here we already computed the value of VR2. If you put that value, you will get the output voltage. So it is 4.17 volts. So that is the output voltage which is available. So from here to here, if you see what is the total gain, it is around 41, right? This is the output voltage, this is the input voltage. The gain is around 41.7, right? Whereas the gain of the amplifier is known as 100. Okay, so why are we not getting the total gain to the load resistance? Because the source will have a series resistance, so some amount of voltage and gets lost out here. Also, the amplifier will have an output resistance. So these are not ideal sources. Had it been an ideal source here, and if this were an ideal source, then you would get the total gain as 100. But because of this practical limitations, there is a series resistance along with the source, and also any amplifier will have an this is a will not have an ideal output voltage. Okay, again there will be series resistance. Because of these two non-ideal because of these two practical resistance which come in series in both these sub circuits, you have the gain reduced to 41.7 rather than getting a full gain of 100. Okay, so this is this problem. Okay. Problem 4, this is on BJT. So if you understand how an BJT works, okay, let me just give an input voltage is applied out here. So a series resistance of 100k is given here, right? This is an BJT. And this is an RC onto the collector at 2 kilo ohms resistance is connected, and a 10 volt output VSC is connected here. Okay, so let's try and find out what is the voltage across an RC, right? So for that we need to know how this BJT functions. Although it's not probably covered in your syllabus as of now, but still I'll just give you the basics. So I'll try and avoid this in your exam, because but still let me just in the theory part at least let me cover this. So this BJT, what it does is, whatever is IB, okay, the IC will be beta times IB. So that is given here in the problem. IC is beta times beta is 100. So whatever a small current flows into the base of the transistor, it amplifies it by a factor of 100. That is how this works as an amplifier. Okay, so that is the basic thing which helps us in using BJT as an amplifier. Okay, this IB, the relation between IB and IC is equal to beta times IB. Okay. And also the voltage across this acts like a diode. So the voltage across the base and emitter will be 0.7 volt. Okay, so this is the equivalent circuit for an BJT. So 0.7 volt between base and emitter, IB, and then IC is equal to beta IB. So this is the equivalent circuit of an BJT. So if you know this BJT will be represented like this, you can do any questions on BJT. Okay, you just have to remember this equivalent circuit. Okay. So if I put that equivalent circuit instead of BJT out here, if you see this is the voltage which is applied here, 100k, this voltage will be 0.7, okay, and there is a current flowing IB which we need to compute now, and then multiplied by BT to find out IC, and once IC is known, you can compute the voltage across an RC. Okay, so the first if you see this loop, it is 3 volts, and we know that the voltage across this base emitter, irrespective of the current which is flowing into this transistor, this voltage will be 0.7 volt. Okay, so that is what we need to remember about BJTs. Okay, so it is not a function of an IB, it acts like a forward biased diode. So the moment you apply a voltage, this voltage will remain 0.7. The current can be anything, okay, ranging in from a few microamperes to milliamperes, but this current would remain constant. Okay, so that is what how an BJT functions. So this is 0.7 volt. So if I have to find out the current which is flowing into the base of, so it will be 3, okay, minus 0.7, which is the voltage across this base emitter, divided by 100k. So there is a resistance out here which limits the current flowing into this circuit. Okay, so 100, so I get 0.023 milliamperes. Now to find out the current through the collector, I need to multiply it with beta. So beta is given in the problem as 100, so I need to multiply it with 100. So you get 2.3 milliampere, that is the current flowing into the collector. So what is the resistance across this RC? So you need to multiply it with this current with that RC value, which is 2 kilo ohms. So you get 4.6 volt. Okay, is it okay with all of you? Anybody has got any doubts? And please let me know. I can repeat things. Okay. If you pay attention in these tutorials and all, exams will be pretty simple. Okay. Only thing with BJT, don't get scared. If you just remember, this is the equivalent model. Okay, so any that this voltage across base and emitter is 0.7 volt, irrespective of whatever current is flowing in this. So you need to model it like this, and then IC will be beta times IB. Okay, so this is only, if you remember this much, you will be able to handle any questions on BJT.
Sir, sir, is this VGT in our syllabus?
Yeah, I will not include any questions on BJT.
Okay, sir.
Okay. For your exams, but I just covered it out here. Okay. Now,
So how 0.7 volt came?
0.7 volt, that is the BJT model, right? Whenever the BJT, when we learn about the BJT, probably towards the end of the course, one day I'll just give a brief introduction about BJT and CMOS. So once you forward bias, this will be a diode, so that will give you 0.7 volt. Okay.
Sir, in every problem it will be 0.7
Yeah,
volt.
in every problem it will be 0.7 volt.
Okay, sir.
Okay. Okay. Don't bother much about the BJT as of now. I will cover these aspects of BJT towards the end of the. So don't worry about the BJT things for your present exams, what you are going to have. Okay. So this is the next question where we got to solve this. So it has got an current controlled voltage source. Okay. Why is it known as current controlled voltage source? Because this voltage plus minus, if you see, it is a function of the current which is flowing here, Ix. Okay. So these kind of things can actually be realized. Okay. It is not just a theoretical circuit. This can be realized. This is, although it is shown just like a square box, but by appropriate circuit design, we can have this kind of things implemented. Okay, so you have plus and minus here, 2Ix. Okay, so we need to find out what is Ix, and 2Ix will be the voltage across these things. So we need to find out what will be the voltage 2Ix, and then once that is known, we need to find out what is Ix, and then this circuit becomes pretty simple. So how to handle these kind of questions? Okay. First we can find out what is the voltage V. Let's try and write an equation for voltage V. This is what we need to find out, right? So 4, right, it is an potential divider right here. So if you see the polarity, so now VC is the voltage 2Ix, I have denoted it by VC, which is known as the current control voltage source. So this VC is nothing but 2Ix. Okay. Now this, if you see the polarity of this voltage source, so you got to be careful with these polarities when you are attempting questions in your exams. It is plus and minus out here, right? So VC will be, so the actual voltage across this will be, right, and to VC, this is 2Ix is, and I have denoted as VC, divided minus 24 volt, because this polarity is again positive on the top and negative. So it will be VC minus 24. This is the total voltage which is available in this loop, okay, in the counterclockwise loop, right? And then you have two resistances, one is 4, one is 6. So the total voltage which will be available across the 4 ohms will be VC minus 24 is the net voltage available in this loop, right? This is 2 VC out here, which is positive on the top, and again it's positive. So these are opposing, but since this is positive out here, so I am taking this to be positive, this has to be negative. So VC minus 24. Again I am using an potential divider rule, where I have 4 ohms here and 6 ohms here. So what is the voltage across 4 ohms will be 4 divided by 4 plus 6. Okay, so I get an equation 2 by 5 VC minus 45 by 8. V is equal to. Is this equation clear to all of you? How this has come?
Yes, sir.
Yeah, it's pretty simple, right? You just have to take care about the polarity. Okay, this is plus, this is minus, this is 2Ix. 2Ix I am presently, time being I am representing it as VC out here. So VC minus 24, because this is opposing it, and there are two resistances. We are interested about the voltage across 4 ohms. 6 ohm is in series with that, so 4 divided by 4 plus 6. Okay, so we get one equation like that. So we need to find out the second equation. Now for VC, it is 2 into Ix, right? So that is given here. Now if I write an Ix, if I try to find out what would be the value of Ix. Now if you see here, the direction of Ix is here, right, from right to left. So now to find out what is the value of Ix, it will be 24 minus Vc, right? This is Vc. It is now 24 minus Vc divided by the total resistance in this circuit, which is 6 plus 4, 10, right? So this is like Vc is 2Ix, right? So 2 is outside available here. And what is the current? It is since the direction is from right to left, you have 24 volt over here, 24 minus Vc divided by 10, that is the total resistance. So you get one more equation. Now you can solve these two equations and get the value of Vc. Okay, so is this problem clear to all of you?
Yes, sir.
Okay. So once you get a value of Vc, then we need to find out what is V. So you can substitute in the topmost equation and you can get the voltages minus 8 volt. Okay, that means this current is going to flow in from in the as indicated as Ix, so that the current is going to flow like that, and hence you get a minus.
Sir, VC is 2Ix.
Yeah, Vc is 2Ix. Okay, Vc is 2Ix. Okay, so this is one problem. Okay, now you have one more problem out here. Find V0 using source transformation. Okay, so can anybody suggest which is the source which I need to transform here? A 250 volt or the 8 amps one?
250.
Yeah, 250 volt. So the current will be 250 divided by 25, so it will be 10 amps in parallel with 25 ohms. Okay, so 10 amps, 25, right? This 8 amps, so 100 and 20 you already have. So you have now you have one 10 amps going on towards the top and 8 amps coming down. So you have the effective current 2 amps going up. So what are the resistances which are now available? 25, 100 and 20, right? So you need to find out the effective resistance, okay, the parallel resistance, which will come out to be 10 ohms. So 2 into 2 amps into 10 will give you the output voltage. Is this problem clear to all of you?
Yes, sir.
Yeah. Okay, for your exam and all, see, whenever you have to calculate a few resistances in parallel, I don't want you to start using pen and paper and apply the formula, because this is not a mathematics exam. Okay, it's an electrical science exam. So as long as you understand the concepts, it's fine with me. You can use online calculators. Okay, I go out here, right? You will have such calculators available. Finally, if you are going into an industry also, and nobody is interested in how good you are in mathematics. Okay, what are the resistances? 100,
20, 25.
20 and 20, right? So you can have n number of resistances, so you just have to do that. So you do the calculation, you get an effective resistance. Okay, so you can use this in your exams also. Okay, because finally when you go to an industry also, you're going to use these kind of softwares. Okay, don't tell me when you go to an industry, you can also consult your friends also. So please permit that. Okay, so now we are still in academics. So so obviously when you go to an industry, you will work as a team, but for exams you will not work as a team. Okay, but these kind of softwares you can calculators you can use in your exams. Okay, don't waste time in mathematics. Okay, so you can find out the effective resistance and compute it. Okay, so there is one more problem out here. here you have an 72 volt being applied, you have a 4 ohm resistance in series. We got to compute this voltage. Again you have an voltage controlled voltage source, okay, which is given by 3V2, and if you see the polarity, it is plus out here and minus out here, and this is the voltage which is coming across V2, right? So we need to simplify this, okay. So again we will do an source transformation. So we'll convert both these into current sources, so that all the resistance will become in parallel, so that will become easy for us. So 74 divided by 4, similarly this will be 3V2 divided by 12, okay. So this is a variable and doesn't mind, so we'll use it as a current source. Also will become a dependent one, so instead of 3V2 it will just become 3V2 divided by 12, okay. So if I do the transformation, this is 74 divided by 4, which is 18 ampere. This 4 ohm which was earlier in series has become in parallel. This 12 ohms which was earlier in series has become in parallel. Now this has become 3 volts divided by 12 ohms. Okay. Now you just have to be careful with the direction of the current. If you see here, this current is going towards the bottom. That is because if you see here, the polarity is plus here and minus here, okay. So this is the mistake generally which students do in their exams. They are not careful with the polarity aspect, so you have to be doubly careful with these polarities, okay. So if you see, this current is going to be going down. So this is 3 divided by 12 ohm and 12 ohm. Now if you have 4 and 12 which are going to be in series, and 6 also, you can have all these 3, 4 parallel to 6 parallel to 12, which will give you 2 ohms, and these two, there are 2 current sources, so that it will be 18 minus 0.25. This is the net current which is going to flow here, right. So 18 minus 0.25, this is 3 divided by 12, and this parallel resistance is computed as 2. So to find out the voltage, you multiply it with that parallel resistance of 2. So that is how you get the value of V2. Again, see, these are the 4, 6 and 12, right. If I go here, 4, no, number of resistances are 3, 4, 6, and 12. So you get 2 ohms here. So you can use these kind of tools, okay. So that's all for today's tutorial. So we'll stop this
Sir,
here.
how you have transformed,
Yeah, tell me.
how you have